multiple values into less space than they would normally take. Let's look at an example here in bitfields.cpp. Copy that and paste it into our working project and open it in the editor here. I'll just maximize this so that you can see it. So beginning on line 5, you'll see there's a structure called preferences, and it has 5 members, 4 booleans, and an unsigned int. And you'll notice that each one of these variables has a little bit of syntax we've not seen before. After the name of the variable, there's a colon and a number. This number represents the number of bits that field will occupy. So a Boolean value doesn't require more than 1 bit. And an unsigned int only requires the number of bits that it'll take to represent the largest number. And very, very few people, I imagine, have more than 16 children. So a number of children can be in 4 bits pretty comfortably for most cases, at least for our purposes here. And you'll notice that down here, beginning on line 15, I initialize this structure and I just use true and false for the Booleans and an integer number for the number of children. And it all behaves exactly like you would expect, except that the entire structure just requires 8 bits. So let's go ahead and bring this back down to size and compile it and run it. And you'll see that it works just as we would expect. So for the true ones, like likes music and has internet, we see that those get printed because we have this simple if statement here, and that our test subject, Homer, has 3 children. So be aware that the language does not guarantee any particular bit ordering or byte packing. So how your data is actually stored in memory is highly dependent on the target machine architecture. This especially becomes an issue if you store your packed data in a file and then expect to be able to read it on a different machine. It's also worth noting that bitfields can be a source of trouble in concurrent or threaded programming because all of the bits in a unit must be read and written at the same time.